I had given two theorems notes on GC. So one theorem was proved over there, and the second part you were supposed to prove and upload on GC, but many of you, I mean, only one student has done it, nobody else has done it. So I'm doing that homework part here. Okay, what we have to prove is, this is the theorem actually, that if f is even, then f dash is odd. Okay, now you have to recall few things over here. First of all, what is even and odd function? So f is even, and okay, f is a real valued function of real value variable. So f is even if f of minus x is same as f of x. So if you replace your parameter x by minus x, it is same as the answer which you get of f of x. And f is odd if f of minus x is minus of f of x. So this is the definition of even and odd function. Another thing you need to know is this f dash. What is f dash? F dash is derivative of f. Derivative of f. So we define f dash x as, f dash x is, you take f of x plus h minus f of x, whole thing divided by h, and then take the limit as h tends to 0. Now the limit of this particular ratio exists, then you say that the function is differentiable and it is denoted by f dash x. We have seen definition of derivative of function, derivative of f at p in its domain. Okay, so in the definition, wherever you have p in the original definition, I'm just replacing it by any number x. All right, and that is what is meant by f dash. After recalling this, now let us go back to the theorem. Key, what is given? F is even, and what is to be proved? F dash is odd. So let's go ahead. So these are the two things which I'm going to use. And then now my proof starts. Given f is even, and therefore f of minus x is same as f of x. What is TPT? To prove that f dash is odd. That is to prove that you have new function f dash, but at minus x, the answer should be minus of f dash of x. This is what you want to prove actually. Okay, so let us consider f dash of minus x. We already know the definition of f dash x. Once again, I'm writing it. F dash x is my limit of f of x plus h minus f of x upon h as h tends to 0. Now in this, I am putting x is equal to minus x. In this particular statement, I'm putting x is equal to minus x. And so I get f dash of minus x as a limit of f of minus x plus h minus f of minus x whole thing divided by h as h tends to 0. So this is my definition. You can see the cursor. This is my definition of f dash x. But what I want is f dash at minus x. So I have just replaced x over here in the definition by minus x. That's all I have done. And now what I want to prove that my f dash is odd, I should simplify this and I should get minus of f dash of x. This is what I should get. Okay, so somehow I should get that minus sign out. Now, what about f? F is your even function. So whether you take f of minus x or f of x, it is going to be same. See, f of minus x is f of x. That is given to you. And therefore, what I get is, this is same as limit of, the first term I'll write later, but the second term is just f of x. Okay, as f is even. F of minus x and f of x are same. Now this f of minus x plus h, I will write as f of minus x minus g. Okay, so I'm doing two steps together. Huh? So as f is even and putting h is equal to minus g. I'm substituting h as minus g. So I'm getting minus x. In place of h, I'm writing minus g. So denominator will also become minus g. And in place of h, again, I'm writing minus g tends to 0. Okay, I'm replacing h by minus g. Now see, as your h is tending to 0, your minus g, h and minus g are same. That will also tends to 0. And if minus g is tending to 0, g is also tending to 0. Okay, because it is tending to 0, na? Becoming very smaller and smaller and smaller. So whatever happens to minus g will happen to g also, because it is tending to 0. So what I get here is, I'll just write limit g tends to 0. Denominator ka minus g will remain minus g only. This you cannot change, denominator. This is also minus f of x. This is also same. Now here what I get is, this is f of minus of x plus g. Okay, I have taken out minus sign common. Now look at this part. This part. F of minus of something is same as f of that something, because my f is an even function. And therefore, what I get in this circle part is, this is f of simply x plus g. Why? Again, the same reason that f is an even function. F of x. And in the denominator, you have minus of g. And here you have g tends to 0. This step is clear. That again, the reason here is, as f is even. So f of minus of x plus g is same as f of x plus g. All right. Now, what do you understand? See, in the definition of derivative of the function, whether you take h tending to 0, g tending to 0, minus g tending to 0, it is one and the same thing. You just need some very small value as h. Its notation can be anything. Okay. So do you see the definition of derivative over here in this step? Only problem is given by this minus sign. This minus sign. So this minus sign can be taken out. I will take this minus sign out, and what I get is limit of f of x plus g minus f of x upon g as g tends to 0. And this part, this particular part is nothing else but derivative of f at x, that is f dash x. So what I got is equal to minus of f dash of x. So we proved, with what did I start? I started with C, f dash of minus x, and I simplified. I have used various facts which are given to me, nothing else I have used, just the facts which are given to me, and I'm getting that we proved f dash of minus x is minus of f dash x. And therefore, my function f dash is, I'm talking about the function f dash. F dash is which function? Is odd. And the proof is over. Okay.